My chosen topic is acceptance sampling with a statistical basis of statistical quality control. It was first introduced as a method to test for defective bullets by taking a small sample size and use it as a representation of the population. This method was invented by Dodge and Romig and were crucial during World War II in order to prevent failures when operating military equipment. This technique contributes to solving the problem of having many faults in any product, from mechanical to electrical parts to things as simple as toys and spoons. In these scenarios, it is used by selecting a sample of any size n out of the lot, which can be represented by the objects in the red circle, and upon inspection it is decided if there are more or the same defects as the benchmark. The benchmark is a minimal number of defects that the supplier can handle while balancing cost and efficiency. If there are more, the whole lot is rejected, but if there are less than the benchmark, the lot is accepted. When utilizing acceptance sampling, you need an operating characteristic curve to decide the appropriate sampling plan. In other words, I'll show you the plan with the least amount of risk, which then must be weighed over the budget. For example, if you want to sample 1,000 bullets out of 10,000 and your supervisor thinks that is too costly, you can use an OC curve to show her why it's necessary to use that quantity as a sample. Engineers have used acceptance sampling to form more efficient methods to review their products. An example from Sulong is the implementation of a tightened and more rigorous inspection on the first 5 lots and use those as the benchmark for the rest of the day or week. Also, engineers have found it helpful to list the methods used in inspection to improve the detection process when utilizing inspection sampling. Potential weakness of acceptance sampling lies within the amount of potential errors per product. An example from the author A.B. Sulong highlights the possibility of there being 200 points that need to be expected, but only 50 are chosen due to time and cost efficiency. And these 50 points are chosen based off the most common failure in previous models. This can result in a reduction in precision when attempting to predict the likelihood of a product being defective. However, Sulong provides strengths to balance his argument by contributing faster delivery, better quality, and lower product costs to the implementation of acceptance sampling. This bar graph shows the percentage of engineers that favor the use of acceptance sampling in order to distinguish the percentage of defective products. And these statistics were taken from 3 different companies. And we're excited.